Today I have to explain approximation entropy codes to reduce the sample size. So first of all, we're listing the data to all the call file set for data set of F patient data, and here we use the F and using the 173 frames because data is divided into 173 frames. Here 5 frames, 173, 256, 512, 1024 and 2048, but for this code is 173 frames, so data is divided into 173 frames. Then here we listing all the data, means our call the files. Here F we call the F data set. So F data set is contain the 100 file set, right? So first of all we call the all 100 file set. So here show that we called all 100 file set. This is the F0012 F100. Then here we divide it into 173 frames. So we divide into 173 frames. Then we take the all zeros to our store the data, and we listing the all the data sets because F001 is contain the 4097 samples. So first of all we call the first file set 200 file set. So here we can store the all 69,000 value so first of all this is the space to 69,000 value. Then here show that we listing the all data sets. Okay, F001 is contain the 4097 samples. So by using the load we can call the all 4097 samples value. So here show that we call the F001 files, and then it's contain the 4097 value. This is shown in the variable file. Okay. Then by using this loop we can divide into frame. This is 4097 divided by 173, so we can divide into 1 to 23 frames, means one samples file is contain the 23 frames. Then n is equal to j into n, that means it's contain the 173 samples. Then x is equal to we can get the 4097 samples in which we require the 173 samples, and then take the standard deviation of all file sets, so we can get the ones value. Okay, by using the standard deviation we can get the one value. This is 35.0287, right? Then we take k value. This is 0.0 to 0.9. This is standard deviation value because we take the data into 1 to 100% accuracy, so we can use the k is equal to 0.0 to 0.9. And then here r is equal to k into sd, so it is multiplication of k into sd, and we can get r because we contain all the data, that is we compared with the r, that's why it's required the r. Okay, that is k value. This is 0.0 to 0.9. Okay, then we take m is equal to 1, that means one value is compared with the only one value, so that's why we can take m is equal to 1. Then we can call the 4 counters. Then we call the first value I is equal to 1 in first one frame set. This one frame set it contains the 173 values in which we can call the first value. So ensure that I is equal to 1, and for call the value this is xi. This is first value is 34 for first frame. Then we can call the second value, that is j, So here show that j is equal to 1, that means kind of, and then j is equal to is also 34, which means it's contain the value with the 34 with 34, and then we can take absolute value, that means xi minus xj, so we can get the zeros value at d1. Okay, here 1 minus 173 minus 1, here n is equal to 173 and m is equal to 1, so 1 to 172's value, because 171 value is compared with the other 172 value, because in frame we can contain the 173 values, right? So we can get one value to 173 value, and when call the one by one. So here xi is equal to xi is equal to here the x is equal to 33, first value 33, and 1 colon 1 plus 1 minus 1, because m is equal to 1 and I is equal to 1. So this is loop is continuously as the 172 times, and contain the next value same as well. This all the value is compared with the here the d1 less than equal to r of I, that means it's compared with the all values with 10 values, and when this value is d less than r of I, then is increase the counter. So here show that the counter 1 is contain the one value, that means first value is less than equal to r of I. Okay, this all the value stores in the count 1. Okay, here also you show that count 1 is continuously increase 1 1, that means all the value is less than equal to r of I. This looping is 10 time looping to compare, because of r of I is contain the times value, means standard deviation, that means one value is compared with the all 10 values. Okay, then we can take absolute value to remove the negative, and then continuous looping is required, and then finally we can get the this looping is continuously at 172 times, because one frame is contain the 172 values, right? So one value is compared with first value is compared with other 172 values. So one by one counter is increased, and this all value is stored in the ICC. So we can get the ICC value is 10, because then count 1 is equal to 0, so 1 to 10. First frame we can get 10 values, right? So then the counter 1 is zeros for calling from second frames. So first frame is contain 10 values. Okay, and then m is equal to m plus 1, that means we can compare two values with another two values. So we can require m is equal to m plus 1, and then get the accuracy, that means accuracy high or low, with compared with the one value to one value, or accuracy may be high in the to compare with the two value to two value. So here show that the ICCs contain the 172 cross 10 values, and this is reduced by the entropy equation. Okay, and then for m is equal to m plus 1, this is compared with two values with other two values, and Same the way for m is equal to 1, and then finally we can get the another 10 values for first frame, and finally we can get the entropy. Here the entropy, okay, here show that the entropy, because first is contain the 172 cross 10 value, and for m is equal to m plus 1 means 2 value, for another 2 value is also get 172 cross 10 value, right, means 172 rows and 10 columns. So this is reduce for using the entropy equation. Here the entropy is entropy plus log ICC of I means 1 value to 1 value, and IDD that means 2 value to 2 value, and we can to divide them and get log, so we can get only 10 values. Here show that